Welcome back to RamZland. Today I want to explore the conductivity of table salt. Check this out. For this investigation, I'm using a 50 milliliter beaker, my Bunsen burner, 2 copper wire electrodes, 2 binder clips, a ring stand, normal table salt, and I'm using a socket extension cord and a 30-watt light bulb. The first step is to separate your socket extension cord into 2 sides and remove the insulation from both ends so it looks like this. Next, put your 50 milliliter beaker in your stand and use binder clips to hold a copper electrode on each side so that they're not touching at the bottom of the 50 milliliter beaker. Then just add 10 grams of table salt to the bottom of your beaker. Make sure it covers both ends of the electrodes at the bottom. So at this point, you want to plug in your socket extension cord. Notice that the light bulb isn't on because these 2 electrodes aren't touching each other inside the table salt. But if I close the circuit with a screwdriver, you'll see that the light bulb turns on. What will happen when we melt that table salt until it becomes molten sodium chloride? Will it become a conductor? Will the light turn on? Let's find out. Okay, we've lit our Bunsen burner. We're gonna put it right underneath our table salt. And slowly that's gonna start to melt the salt. When it becomes molten, let's keep our eye on the light bulb and see if it turns on. Let's find out if molten table salt becomes conductive. Okay, at this point, our table salt is almost molten, but our light still isn't on. So I'm gonna add a little heat from above. Did you see that? It's on, and now it's out again. So the salt has to be molten. Let's get it hot again. There it's on. There it's on. Now watch. And as the salt cools down, it'll slowly go out. And it's out. So why does the salt become a conductor when it's molten? Think about it. So in this demonstration, when sodium chloride or table salt turns molten, it's so hot that those sodium ions are free to move about as charge carriers from one electrode to the other, thereby completing the circuit and turning on the light bulb. Kind of reminds me of the new sodium-ion batteries that are meant to complement our already lithium-ion batteries that are used in our cars. Now, sodium-ion batteries are not going to replace lithium-ion batteries. For one, they don't last as long. Sodium-ion batteries will last for about 2,000 cycles, whereas a lithium-ion battery will last for about 3,000 cycles. But it reduces our dependency on lithium, and it's much cheaper. For instance, last year in April of 2023, China released its first sodium-ion powered EV vehicle. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.